All right, everyone. Welcome to the Advanced Materials Showcase. We're happy that everyone is joining us. Today's agenda, it's going to be two sessions. Hopefully, we're going to run through them fairly on time. And to give a little bit of background for those who aren't familiar with Deep Tech Showcase, if this is your first event, second event, third event, I'm going to be a broken record. It doesn't matter. What Deep Tech Showcase does is we help dual use technologies come to market. We do this by leveraging a community. It doesn't just take a fantastic idea in order to get funded and get through all those steps needed in order to really find the traction you need. Rather, it takes, grants, it can take investment, it can take partnerships. So what we do is we try to gather all of those players, all of the stakeholders, as we call them, into one Zoom room, as it is today, and showcase some really cool, interesting dual use technologies that we come across. So the showcase events, you're at one of them. We have one per month. Each month, it's a different theme. So this is advanced materials. The next one's going to be energy, which is probably fairly related. We're going to probably see some familiar faces at the energy one as well. Then after that is autonomous systems, which is probably going to be an interesting one considering world events. In addition to the showcases, we also try to support the community by pursuing matchmaking in between the showcases. So if you see a startup that you find interesting and you want to speak to them and get a better idea of what they're doing, feel free to reach out to me. We're always happy to make a connection. Alternatively, almost all of the companies, if not all of the companies, are probably going to leave contact information on the slides today. So feel free to take advantage of that. Feel free to email them. You don't need my blessing. The goal is to create as many connections as possible, even in the showcase, outside of the showcase. So if you have a specific focus area that you're looking for deal flow in and you're on the call, feel free to reach out to me. I'm always happy to help. Not always promising that we could find the right people in the right places. That being said, we usually have a pretty good grip on the market, aside from some niche edge cases that have people have brought to me that have been interesting to look for at least. Our next upcoming events, as I mentioned before, it's the Energy Showcase and Autonomous Systems. Feel free to sign up, join us for those. And now we have a word from our sponsor, Eagle Point Funding. David, take it away.
Hey everyone, I am David Fertig from Eagle Point Funding. Basically, Eagle Point Funding is the overall company here. Deep Tech Showcase is one of our amazing departments, and I'm not going to take up too much time, but just to give a word about what we do. We are on the grant side of things. So we help companies do anything and everything required to help them get non-dilutive funding from the federal government. So SBIRs, BAAs, OTAs, all the acronyms you can think of. And part of that, we typically work with companies over 18 months, helping them go after 15, 20, 25, more than that, even different proposals, and help them find and write them. And then, of course, everything as well that goes on with the Deep Tech Showcase is also part of what we help with. And that's really all. If there are any spectators in the audience who are interested in speaking to me about how this might relate to their particular company, I'm happy to get on a call. You can scan that QR code or anything like that. I'm also going to leave my information in the chat. There's a Calendly link here, and there you go. With that, I'll hand it back to you, Asher. Thank you.
Thank you,
Everyone enjoy.
David. Oh, well, thank you, David. I appreciate that. Yeah, and feel free to speak with him. I'm a big fan. All right. In terms of companies presenting today, session one, we are going to have Rebuild, Caporis, I hope I'm pronouncing that right, Clarity and Superseed. Session two, we have Heatpath, Purefresh, Dasco, and Eternal. Now, we're going to do a little bit of a roundtable and have the panelists introduce themselves. In addition to that, I would also like them to talk about a little bit about what kind of interesting technologies they're looking forward to, or I'll give it two choice answer, not both, but one or the other. What your outlook is on current market trends and what you're thinking, especially for the advanced material, startup space, what your thoughts are. So with that, we're gonna start going around and Samira, why don't you kick us off?
Sure. So I have to pick between the futuristic thinking or what our focus is.
Yep.
Okay, I think I would leave the futuristic thinking to another session because like I have a lot to share about that.
Sure.
So yeah, Samira, I am a venture partner with a VU fund, and I'm also running an accelerator program, which I started in going to raise $100 million between now and the next year. And yeah, my focus is pretty much on Web3 and artificial intelligence, and with the weakness for, of course, impact, which I think it's a is a common sense these days, right? So how we just impact the world. So the today's session is very interesting for me. So I'm actually very well, I'm looking forward to meet the founders.
Absolutely.
Mhm.
We're happy to have you. Han, you want to go next?
Sure, Han Ko here. USACO Group is my company that I founded. I'm serve as a president CEO. We're basically a VC investment company and based out of USA. But what's unique about it is that we have an office all the way to Asia, specifically Seoul, South Korea. So we have pretty strong connection there. We have a pretty strong interest in advanced material these days. That's what we hear. And in about our future, our opinion about the future, I'm pretty optimistic about it, especially with our global vision and trend that we see on daily basis. With all the things going on in the world, this especially in innovation and especially in the advanced material and AI, they all merge together to one point. I think it's going to make a great difference, and then we can. It's going to bring us a lot of investment opportunity. So looking forward to working with you all. Thank you.
Absolutely. Thank you for joining. Matthew Cohen.
Hey, everybody. Matt Cohen of Clean Energy Ventures. I think I'll pick the option of telling you a little bit about us, though we'll try to be very brief. So we're a venture capital fund investing in startup companies commercializing technologies that can reduce CO2 equivalent emissions by multi-gigaton type scale over the next 30 years. And we certainly are excited about a lot of advanced materials related technologies that can help in those decarbonization efforts, typically focus on the kind of seed Series A for first checks. So with that, want to reserve the majority of our time to hear from all the exciting companies.
Absolutely. Thank you, Matt. All right. Next up, Carolina. She can hear
Sorry,
me.
let me unmute myself. Hi, hello everyone. So we are so I'm a partner at Starbeam Capital. We are a London-based VC, yes, focused on hardware solutions, predominantly in the energy space and industrial sectors. We look for seed stage startups with high growth potential, and new and advanced materials are a big focus for us. We like that the materials can be used in multiple verticals, and we see a lot of activity in the battery, especially in the energy and the battery areas. Also CO2 negative materials and anything that improves efficiency. So a lot of even like going into chipsets and compound semiconductors, new types of sensors. So yeah, very exciting space, I think. Thank you.
Absolutely. Happy to have you. Thank you for joining. Next up, Bill Weber.
Hi, I'm Bill Weber with 3M Ventures. 3M is working on a lot of its own materials and climate tech, but we're also looking to work with startups who would rather use the capital we've already spent to make manufacturing facilities for advanced technologies and help them scale. So, and any of the other VCs out there, if you've got people approaching that point, we should have a conversation.
Absolutely. That's awesome. Thank you for joining us. Next up, Adarsh Sokar.
Hi everyone, my name is Adarsh and I work for Nova by Saint-Gobain, and we are the corporate venturing group of Saint-Gobain. For those who don't know, Saint-Gobain is a French material science company, about 55 billion in revenue. Our purpose is to make the world a better home by providing light and sustainable building products for the construction sector and providing decarbonization solutions for the industrial sector. So a lot of the technologies and startups that we are interested tend to be, focused on advanced material innovations. So we're looking forward to connecting with startups with advanced materials technologies. Thank you.
Absolutely. Thank you for joining us. Jonathan Wu.
Hi, John from ITIC, the venture arm of ITRI E3. And ITIC was actually founded in 1979 with the purpose of spinning out technology, a company like UMC and TSMC back then. So that's actually where we got our kind of seed money. And beside the evergreen funds that we have, we also have joint venture fund with Applied Materials. And also we're forming another fund with OurCrowd, which I'm pretty sure Ashar is familiar with. So yeah, I look forward to hear all the material startup today. Thank you.
Absolutely. Absolutely. Very familiar. That's awesome. Lisa Dufresne.
Hi, Lisa Dufresne. I'm with GC Ventures. GC is a petrochem refinery in Thailand. So we make commodity chemicals, commodity plastics. We also make biodegradable polymers. We have 2 JVs where we make 2 different ones. We make acrylate resin products for the paint and coatings industry through one of our wholly owned subsidiaries. We make a lot of things. I have a giant map, which I won't bore you with, but our investment thesis is really around advanced materials, particularly bio-based materials or bio feedstock to make some of the petroleum-based materials we make today. So we're very interested in that. Clean tech, like everybody, we're looking for, again, sort of alternative ways to maybe make some of the materials we make with a lower carbon footprint, whether it's bio-based or via electrolysis or something like that. And then circularity, we're very interested, again, via the sort of biodegradable polymer aspect, interested in materials that provide some kind of circularity. And happy to be here. Love this program.
Happy to have you. Awesome. Samuel Kim.
Hey, Asher. Hey, everyone. My name's Sam. We have a venture capital fund called Banget Ventures. We're based out of Austin, Texas. Our investments focus is on what I call the hard sciences, advanced materials, nanotechnology, semiconductors, photonics, etc. Really honored to be part of this group. I see why Asher's put all these investors together. A lot of every single one of our deals actually we've done with a corporate venture partner. So that's part of our investment strategy. And there's not very many of us. So I think we need to all work together. So I'm looking forward to some these startup companies pitch today. Thank you.
Absolutely. Thank you for being here. All right. Thomas Bloom. I know he was here earlier. I don't know if he's... Thomas, can you hear us? All right, we'll come back to him. Keith Gillard.
Thanks, Asher. Hi, Keith Gillard. I'm CEO of Upper Stage Capital and also co-founder and chairman of Foresight, which is Canada's largest clean tech accelerator. So that's my nonprofit hat. We've had over 1,200 clean tech companies through our programs over the last 11 years, a number of which are in the advanced materials space. On the for-profit side of things, I worked in advanced materials venture capital for a long time, several years with Matt Cohen together at Pangea Ventures. Familiar, I see a couple of our LPs here in the room, so nice to see you. But for the last few years, I've been more focused on the lower middle market, more private equity model, looking at companies in the $2 to $8 million EBITDA range. Again, dealing with a lot of materials type of things, continuing to play in the areas of my strength. Clarity, that's going to be presenting today, is a company familiar to me as I've been doing a lot of work in the remediation chemistry space lately. So I'm excited to see their update.
Absolutely. Happy to have you. All right. Next up, we have Martin Hoof.
Hi, everyone. I'm Martin. I'm the GP at Quest Venture Partners. We're an early stage venture firm based in Menlo Park. We do pre-seed, seed, and Series A, and we're sector agnostic. We'll look at all kinds of opportunities. And advanced materials is one of the areas that we're currently investigating as an area for investment.
Absolutely. Thank you for joining us. Raymond Zhang.
Thank you, Asha. Can you hear me? Yes, good.
Yep, loud and clear.
Yeah, hey, this is Raymond Zhang. I'm Senior Managing Director of Honda. Actually, the program is called Honda Accelerator Venture. We invest in early stage startups, $1 to $5 million check size. Usually, seed A, B is usually our sweet spots. Reason I'm here, why are we interested in advanced material making cars? Of course, really just follow the few corporate kind of initiative or vision is zero collision, which maybe not much to do with advanced material, but the other part zero carbon, which has a lot to do with energy and also recycling. So very interested. There are a lot of advances in materials and batteries, fuel cells, hydrogens, any sort of catalyst. We're all interested in different energy sources and how these chemistry make it more efficient. And also recycling part, we're very much interested in how to get rid of the harmful materials and how to rebuild a car from an old car, so to speak, using the same materials, and advanced material actually plays a big part of it. So that's why I'm here, looking forward to it.
Absolutely. Thank you. Thank you for being here. All right, next up we have John Zakowski.
Yeah, hi. So I'm the Assistant Director for the New York Angels, one of the world's largest, most active single chapter angel groups. It's industry agnostic, but members really have expertise across the board. So anything deep tech, clean tech, anything like that, there's interest from the group. So looking forward to seeing what we have.
Absolutely. Thank you for joining us. Next up, Rudy Beza. I know he was on before. Yeah. Let's see. We could come back around, Rudy.
Yep. Trying to find a mute button. Hey, welcome, guys.
There you
Thanks. I've been doing this for a while. So my name is Rudy Beza. I'm based out of Edwards Air Force Base. Focus on RDT&E, research development, and evaluation, and we're focused in aircraft maintenance specifically, but we're open to other innovation ideas out there. For example, the other day we were speaking to members on EV and eVTOLs, and then others like AR/VR. So we're always open-minded for other things that helps out the entire base and pretty much all of DoD. So that's it for me. Thanks.
Absolutely happy to have you. Next up, Takeo.
Hello, everybody. I'm Takeo, manager of CBC in DIC. DIC is a Japanese chemical company. We sell the ink, polymers, pigments mainly globally, about the $7 billion the sales. We are seeking for the sustainable energy, sustainable packaging, healthcare, mainly materials. Yeah, looking forward to discussion today. Thank you.
Absolutely happy to have you here. All right. Last but not least, we have Peter Wes.
Hi, everyone. So although I'm based in Los Angeles, I do work for the Kansas Department of Commerce under Lieutenant Governor David Tolan. I'm also working, my main role is business recruitment, business attraction, and also working with our Office of Innovation on rolling out new incentive programs and really new programs that help investors and companies themselves. So any questions regarding Kansas, let me know.
Absolutely. Thank you for joining us, Peter. All right, with that, we introduced the panel and we're actually running exactly on time to the minute. So it's a good sign. All right, we'll start with Rebuild. Rebuild, feel free to start sharing your screen whenever you're ready to start sharing, and we'll get going here.
Sounds great. And can everybody see my presentation?
We can, yep, now I can see it presentation mode. Looks good.
Excellent. Well, thanks for everybody's time. Quick introduction, Eric Smith. I'm VP of Sales for our components group. So that supports 4 out of our 12 sites across the Rebuild manufacturing network. I'm located just outside of Charlotte by our Rock Hill, South Carolina composite facility. So advanced materials and process is definitely a core competency and strategic focus of ours, and certainly in the aerospace and defense community. So about 2/3 of our business does support various commercial aerospace and or defense platforms, and that's working with all of the sub-tiers or certainly the primes or the OEMs direct. So who is Rebuild? So Rebuild stood up about 3.5 years ago, raised about $500 million from private money. We want to be very clear, we're not private equity. So all of the businesses that we identify, acquire, and integrate is really with the intent to never sell and or spin them off. So this is really with the thesis and the purpose of reinvigorating U.S. manufacturing with various technologies and capabilities. Again, with advanced materials and process being a core focus of ours. So throughout the journey, the last 3.5 years, you know, we have acquired 11 companies and built our first brownfield site last year just outside of Pittsburgh. So we're 12 independent sites across the group, but really strong collaboration and connective tissue, you know, to really be a complete and value add supplier to our customers and the various industries that we support. And again, with aerospace and defense being one of the 5 strategic industries that we've identified as core capabilities and competencies to us. So as I said, you know, we're really brain to box. So we can do everything from conceptual design and development to low rate prototype and LRIP type volumes, and then full rate production components and or value add sub-assemblies, and all the way through you know, purpose-built automation for high rate technologies and repeatabilities, performance, and cost. So, you know, how are we really looking to reinvigorate and you know, bring some sustainment to you know, to the, you know, military industrial base? So you know, one of it is we're really building ahead in capacity. We're expanding, and I'll talk to that later in the presentation. You know, we're expanding by hundreds of thousands of square feet as we speak. That's really an aggregate across our 12 sites. But of the 4 sites that are really supporting the aerospace and defense community, you know, making sure that we do have with the ever increasing cybersecurity compliance requirements, that we're proactive and ahead of that, and you know, continuing to build off of our pedigree and heritage in defense, and adding more and more content and value add to our customers. We're also looking at redundancy and adding capabilities across multiple sites for risk mitigation and to satisfy any dual source requirements. So as I said, you know, in my world, we really make metallic and composite structures and assemblies, and that could be everything from fixed wing to rotorcraft to sea to vehicular to protective and supporting certain survivability requirements. And it's you know, we're materials agnostic. We do a lot of metallics, but also a lot of components and structures in thermoset and thermoplastic composites, and also multi-material solutions. So you know, when we say advanced materials, we also think advanced process, and you know, looking at automated capabilities to really influence, you know, the labor shortage that everybody sees, and making sure that, you know, just the supply chain continuity is well understood and highly confident. So as I said, you know, 12 sites. So the 4 sites that are really supporting this industry is Composite Resources outside of Rock Hill, South Carolina. That's 60,000 square feet of composite fabrication capability. So that's filament winding, hand lamination, compression molding, etc. But very good process diversity. Cutting Dynamics outside of Cleveland is about a 200,000 square foot 4-site campus, metal fab. So that's everything from laser cutting to hydroforming to press braking, along with 30 plus CNC work centers, and you know, various capabilities all the way through assembly and kitting. And then our Answer Engineering site is a very highly pedigreed 50-person engineering house, mostly for composite aero and defense structures, all the way into and throughout FAA certification is part of their core competency. But very, very good subject matter expertise in landing gear development and testing, blade testing and development. And they would be on programs that this audience here would know. And then Orbi Composites is that's more high rate structural thermoplastics. So think lightweight helmets for SOCOM and some of the high tempo units. And then, as I said, expanding into Pittsburgh, which I'll talk through later in the slide. So we're about 1,000 people throughout the network. Almost half of our personnel comes from some type of engineering discipline. So we're a very engineering centric organization, really looking for solutions. And certainly as some of the requirements are increasing, making sure that we have capabilities and competency to meet and collaborate, to meet those requirements and collaborate closely with our customers on DFM and manufacturability processes. We also know that speed and responsiveness is important. Certainly the ability to iterate and do that quickly. Certainly in some of these emerging application spaces, and with the ever increasing trend into autonomy and electrification. So making sure that we have the ability to do that, and not just for cost and performance, but for repeatability and throughput. So that's a big
30-second warning.
Sure, thank you. And whoops. So as we look at our capabilities in aerospace and defense, again, very, very competent in composite structure. And how are we, are we expanding to support the military industrial base? Absolutely. And so, almost 250,000 square feet of additional manufacturing space just being added this year, with options up to 1 million. So, we're proactively expanding that capability throughout the enterprise. So our ask is that we're really looking for collaborative partners, that want a strong manufacturing partner that's here to stay and has the corresponding accreditations, whether it's ITAR, AS9100, and certainly the cybersecurity compliance and capability. So with that, I thank you for everybody's time.
Absolutely. Thank you so much, Eric. All right. I mentioned it in the chat, but I don't know if anyone saw it. Whoever has a question, under React, there's a raise hand thing. If not, just feel free to unmute yourself if you can't find it. But we'll try to answer the questions in the order in which the hands are raised. Otherwise, you can always just pipe up.
I couldn't find the hand raise button, but I'll go ahead and ask the question. So thanks for the presentation. So I guess the question would be, what sort of partnership or engagement do you envision to have with everyone here on the call? Are you looking for sort of fundraising or partnership or both? And if so, any specific topics or ideas in mind?
So I wouldn't say we're specifically looking for fundraising. We have a separate team that would manage that. We're very well capitalized, and we're not afraid to deploy that capital. So we've deployed about 2/3 of our capital to date in either expansion or asset additions. So we really just want to identify people that want to, that have a need for these types of structural solutions, and would like to collaborate with a manufacturing partner that's here to stay. So again, we've got a lot of pedigree and expertise in the defense community. So we want partners that think we can add value into their supply chain.
Okay.
Does that answer your question?
Yep.
Sure. Lisa, you're up.
Hi, Eric. So I'm curious to understand whether you're interested in working with companies that are developing new composite materials. I mean, we're a materials company. We have a composites lab. We're always looking to, develop something new. Is that the kind of partnership that you're interested in as well? Or are you really just looking for, you have your composite processes and you're looking for customers that would tap into that?
No, 1,000%, Lisa. I mean, some of our we work very strategically with various raw material suppliers. They can be our best advocates sometimes. And so, material technology is, we don't make raw materials ourselves. So, whether it's different reinforcements or polymer systems or, pre-impregnated materials. So, absolutely. That's instrumental to our business, and, working closely with various materials suppliers would be of high interest, and we do it today.
Okay, thanks.
Absolutely. Eric, I believe that's the time we have, but thank you so much. Oh, Carolina, last question. All right, last question. You can
Sorry,
go.
quick
Sure.
one, just following, piggybacking a little bit on Lisa's question, right? If you're so we work with a lot of startups, right? But that are looking for manufacturing abilities in the US, let's say. But then are you prepared to work with the smaller companies like startups? Are you focused on bigger players like Lisa maybe?
Yeah, we work with all customer profiles, Carolina. So absolutely. And we work with many startups today that have, emerging technologies or ideas. So absolutely.
Okay, thanks.
Sure. All right. Yeah, like that's definitely the time. But thank you so much for presenting. Feel free to leave your contact information. And I'm sure some folks here will reach out. Next up, we have Kaporis. And feel free, Kevin, to go right ahead.
All right. Thanks a lot, Asher. Can you see the slides now?
Yep.
All right. I'll get going then. Well, good afternoon, everybody. My name is Kevin O'Connor. I'm CEO of Kaporis Technologies. I'm happy to be joined today by my close colleague, Carl Trainer, who is Chief Commercial Officer, and he'll join us in a few minutes as we get into some of the questions. So we are an advanced materials company applying our materials for electrification. So don't need to tell you too much to know that there's a whole lot of generation storage and electrical consumption growth happening. And where we fit in is actually for the energy storage and the power conversion that connects all these systems. So specifically, capacitors do provide that intermediate energy storage to link, generation and storage and consumption of electrical power. The convenient example of power conversion is if you're participating through your laptop, that box that you're plugging into interface your laptop with the grid is a good example of power conversion. But where we really are focused are for these more demanding power conversion applications coming online. One good example is for both onboard electric vehicles and then the supporting fast charging infrastructure. So to focus on that, just for the purpose of an example here, if you're looking on board a vehicle, a modern vehicle will have over 10,000 capacitors in it, but we're not focusing on the more commoditized capacitors. What we're actually focusing on are these higher value capacitors that are facing these more demanding requirements for power conversion. So the capacitors within the traction inverter, which is linking the battery pack to drive the electric motors on board the vehicle, and then within the fast charging infrastructure, these DC to DC and AC to DC converters are good examples. And so to meet these needs, we're part of a larger power electronics trend towards higher voltage and higher power in this electrical power conversion. You may be familiar with the transition to wide bandgap semiconductors for power semiconductor devices. So this transition from silicon-based devices to silicon carbide and gallium nitride. As that transition happens, we provide the complementary technology in the capacitors to meet these demands for higher voltage, higher frequency, and higher temperature of operation. So when we talk about high voltage in the terms of these types of power electronic systems, we're usually talking about 1,000 volt requirements plus or minus 200 volts. But a big requirement there is higher temperature. So a common requirement that we're getting is for 150 C, and that's for that intimate integration of the capacitors with these more advanced power semiconductor devices. And then, of course, to provide that all in a high reliability package, so film compatible for a self-clearing performance. And then, of course, to have the energy density to put this all into a reduced footprint. So the capacitor market is, of course, well established and growing, but where we're really focused is on the right here, where there's projections for close to 10% growth for these high voltage capacitors going into these more demanding power conversion applications. And that's really where we've targeted development of our technology. So when you're talking about advanced materials for capacitors, what it really gets down to are the dielectrics, or the electrical insulators that go into those capacitors. Conventionally, that is either a solid ceramic or a solid polymer. But since our founding, we've recognized that there are limitations to these solid dielectrics, and we implement a different approach where we actually implement a porous ceramic with a material that is described by nanoscale lamellar porosity. So I don't have the opportunity to go into the weeds of nanoscale lamellar porosity with you today, but the basic idea is to say that we have a porous ceramic structure with a layered structure, and that porosity is kept at a nanoscale. The ultimate idea there is that we're actually able to control the electric field distribution within this porous ceramic structure. Since it is an advanced materials technology, it can actually be applied to a lot of different applications. So what I'm focusing on here is our application in film capacitors, and that's really where we've gotten our start and where we have significant customer traction. But as the company has done a lot of customer discovery, we've been getting a pull to apply our materials into semiconductor devices as well. And so you'll see here in this Venn diagram, we're expanding beyond just the film capacitor opportunity into putting these capacitors directly onto semiconductor chip, then also applying our materials directly onto silicon wafers for this engineered substrate, this higher value silicon wafer. So won't go through all of this right now, of course, but just to contrast with what we're providing with our coated film capacitors on the right, compared to traditional ceramic capacitors on the left and film capacitors here in the middle, we're really bringing a combination of the best attributes of both, where we're providing the high temperature performance that you would get from ceramics with the processing flexibility and the stability of parameters that you would get with films. So our technology in nanoscale lamellar porosity has been patented in the US, Japan, and China. That's all owned internally by Koporis. And then our IP portfolio is growing as we've been implementing this. So what we've demonstrated over the last 18 months is taking this materials development and expanding it into pilot production. And so, this is produced as a slurry ink, which is then coated on a roll-to-roll scale, where we're at an interesting inflection point in our trajectory right now, where we are producing rolls of material where we're able to provide both raw material and package capacitor prototypes to serve our prospective customer
30
requirements.
second warning.
Thank you very much. So wrapping up, we got our start developing our materials incubated at Argonne National Laboratory in the Chicago suburbs. That was during the COVID years, and then coming out of that, we raised our seed funding, $3 million from Volta Energy Technologies. And so that seed funding, combined with the non-dilutive support from the DOE and NSF, has got us to this point where we are now providing materials and prototype capacitors to a range of customer power management OEMs and capacitor suppliers. So we have about 12 months of runway, but in light of this inflection point where we are now, we are socializing a Series A raise, and we anticipate launching that or opening the data room within this quarter. So we're a core team of 6, complemented by the board of directors, including the CTO of Volta Energy Technologies and Jim Cable, former CEO of Peregrine Semiconductor, or P-Semi. And so to wrap up, we look forward to connecting with you. I'm Kevin. Carl will join me here for some questions. Thanks a lot.
Perfect. Thank you, Kevin. Martin, you're up.
Yeah. Hi, Kevin. Thanks a lot for the presentation. I was wondering, the idea of this nanoscale lamellar porosity, is that unique, something that you guys uniquely developed, or is that something that you guys found a better way of manufacturing it, or getting a yield rate higher? What's the sort of the key development?
Well, that's a great question, because so the IP that I mentioned, those issued patents are for the material itself. So materials incorporating this nanoscale lamellar porosity. So that material structure itself is patented, and what we've really developed over the last 18 months and looking forward towards our Series A, we've from the manufacturing side, we've demonstrated how we can manufacture this using existing roll-to-roll equipment, but there are some manufacturing side innovations that's a part of our growing IP portfolio.
Great, thank you.
Matt, you're up.
Hey, Kevin, good to see you again. Wondering if you could just kind of contextualize the value of what you're doing within a market like EVs, both on board and for charging. So why should we believe that this is going to significantly change how those markets will evolve in the next couple of years?
Well, a big part of that is this transition to 800-volt systems. And so, part of that, today, the Teslas that you see on the road, are 400-volt systems. The industry is transitioning to this 800-volt bus system, which is part of those more demanding requirements that are being placed on the power electronics, including the capacitors. What 800 volts, there's a range of advantages that provides. One that we're focusing on is the fast charging aspect. So if you can, transfer more power, you can do that by implementing higher voltage but at lower current. And so we're a part of enabling that type of system. There's a lot of side advantages to doing that transition to 800 volts, including reducing some of the other raw materials and cooling systems that go into the EV. But I would say that the enablement of fast charging and how that is made possible by these higher voltage power electronics is a big part of the transition in the power semiconductor world, and then our complement to that to be compatible with those high voltage and high temperature requirements for those wide bandgap semiconductors.
I might just build a bit on Kevin's answer to Matt, that one of the biggest obstacles to broader adoption to electric vehicles is that fast charging component. Folks are so used to, with their combustion engines, being able to roll in, roll out of gas stations to refuel. There's opportunity with fast charging to break through to mainstream adoption of electric vehicles and potentially smaller battery sizes, which has all kinds of additional benefits if we're able to recharge faster.
Perfect. Last question.
Yeah, can I have also?
Okay. Takeo and then Raymond. Okay.
All right.
Hi. Can I ask your business model? What you are selling, the capacitor or coating film or slurry, and also your core technology is the I think material and process. The mix of the material and the process is your core technology. However, like I say, to imply this new capacitor, customer need to change their I can say the installing the system or not to business model, and is it like I say install easily or not?
Yeah, I can start to address that. So where we are right now, we're engaging with customers at various points in the supply chain. So we have power management OEMs who are requesting packaged prototype capacitors directly from us, kind of skipping over the legacy or more established capacitor manufacturers in that case. But at the same time, we are having active discussions with those established capacitor manufacturers who are looking to integrate our materials into their product lines. And so there is a little bit of a hybrid business model where we can work within the established supply chain, but then also we're getting that pull directly from the end users, the people who are actually doing the integration of the power electronic systems.
Understood. Thank you very much.
Raymond, last question.
Yes, thank you, Kevin. Can you speak a little bit about the cost, because it's one of the things about making cars is really cost sensitive because of the margin. To do this, you probably have to go through some specific process. The cost will probably be higher, but I just trying to understand the projection wise. When do you think is going to be ever going to be on par with the existing solution at all?
I might jump in, Raymond. One of the interesting things about this, those requirements, and you saw in the competitive matrix, are not being met currently buy material one-for-one replacement. The performance that Kaporis material offers actually allows the elimination of cost and complexity in the system. So the value proposition that we're hearing back from EV manufacturers, power system manufacturers, is that there's premium to be paid. That being said, it's also true that Kaporis is using materials where we're able to use thinner films, thinner metallized films, and the cost of our materials is really not incrementally disruptive of price. So we're actually very competitive with cost, but have a really substantial price premium that manufacturers appear to be interested to accept.
Thank you.
Perfect. Perfect. Thank you so much, Kevin and Carl. We really appreciate the presentation, and feel free to leave the contact information in the chat. I know it was on the slide, but feel free to leave it in the chat as well. And I think there's a few Q&A questions as well in the Q&A box and also in the chat. So be on the lookout. Next up, we have Aclarity. Feel free to start presenting whenever you're ready to go. Perfect.
All right. Hi, this is John Tracy. I am the head of business development for Aclarity. I want to make sure, Brian, can you see the presentation and hear me okay?
I can see the presentation and I can hear you.
Excellent. Okay. All right. So we'll go. So Aclarity is a provider of a specialty environmental technology. And I think the reason we were invited to a new materials pitch session is because, especially in EV battery and EV battery recycling, there is a there are materials, membranes and things like that, that are using or have PFAS in their composition, and for good reason. It's a material that is purpose built to suit some of the requirements that EV batteries have. Aclarity is working with some of the battery recyclers and with customers in the semiconductor industry to help them deal with PFAS by destroying it on site instead of capturing PFAS with a media such as activated carbon or specialty ion exchange media and trucking that material off-site for disposal or incineration. So that's what we bring to the table, is the ability to destroy PFAS as part of your typical wastewater treatment plant.
Hey, John, I don't know if you're switching. Oh, there you go. Sorry.
Yeah, I just switched. Yeah. The company was founded in 2017, so we're about 7 years old. We're out of the University of Massachusetts in Amherst. And our co-founder, together with Chief Science Officer, were kind of the founding developers of this technology. We are currently at a TRL level of 8 or 9. We have done multiple demonstration projects, mostly in the landfill industry or with central wastewater treatment plants. And we have built and deployed our first commercial system, which I'll show a snapshot of later in the presentation. That is at a landfill site in New England. I'm talking to you from New Hampshire in New England right now. The company has gone through commercialization, early commercialization, improving out of our technology. We've been through a seed round of fundraising of about $4 million, and then a Series A round, which was completed just the end of last year. So as far as fundraising goes, we're capitalized well for now. We'll, by the end of this year, beginning of next year, look to go out to the markets for a Series B round of fundraising. Where does Aclarity operate in this new and growing PFAS mitigation technology landscape? Aclarity is in this destruction space, which is the bottom right quadrant. We are working in conjunction with different concentration technologies, or we'll handle wastewater streams directly. The concentration technologies are things such as reverse osmosis, nanofiltration, foam fractionation, which is a technology that's been adopted by companies who want to treat and destroy and or capture PFAS. There's a measurement and monitoring part of this ecosystem, which is very important. It's a new and emerging set of monitoring technologies that we're all dealing with, we're all working with in real time. There is no quick online monitoring for PFAS to show you how your destruction is going. And then finally, the original technologies involved were all about capture and disposal, which is up in the upper left quadrant there. These are the activated carbon, the ion exchange resins, sending wastewater to disposal wells, things like that. So Aclarity is down here, bottom right in the destruction space. So I'll talk about that as we go forward. The technology works by using free electrons that our electrochemical oxidation reactors generate. They generate these free electrons at the anode surface of the electrodes in our system. Those free electrons are an oxidant, but the important thing is that they have enough oxidation potential, enough energy in them to break the carbon-fluorine bond. And there are not many other oxidants that are able to do this. That's why our technology is well suited to PFAS mitigation. What we're doing in creating these free electrons is called direct oxidation. Along with that, in the reactors we're running, the system is generating a lot of other general kind of indirect oxidants, things like hydroxide radical, chlorine oxide radicals, hydrogen peroxide, things like that. If you look at the Beaker study down at the bottom right, a lot of that indirect oxidation is going to break down color and odor in the very difficult streams we work at. We're very good at destroying and breaking down ammonia, COD, which is a kind of a de facto measurement of total organics in a water stream or a wastewater stream. We're very good at that, but the main focus is these free electrons and PFAS destruction.
30 seconds remaining.
Thanks. I've got to speed up then. The company's evolved from small test systems, which we developed the technology on, through to like a single chamber demonstration system that we can run in field projects and pilot sites, to our commercial system, which is an 8-chamber system that can run about 30,000 gallons per day and destroy PFAS in a range of streams. Our areas of focus have been on landfills and landfill leachate, the wastewater that percolates out of landfills, groundwater remediation projects. There are many in the industrial and military sectors in North America, also in Europe, are 2 markets that we work in. We've had inquiries lately from Japan. Japan is starting to gain a lot of concern about PFAS in their country as well. The final area of work, we're starting to work with the semiconductor industry, and their particular PFAS compounds are newer, less I don't want to say deadly, I guess, what's the word, but less concerning, but still are problem compounds. They're shorter chain, they're compounds that the industry cannot get rid of. And so we're helping to develop on-site destruction of those products. And then I'll show my information here at the end. I'll put this in the chat as well.
Sure, absolutely. Thank you so much, John. Han, you go first, and then after that, Keith.
Alrighty, John, thank you for the presentation. Very impressive technology. We've been paying attention in this PFAS destruction removal for a while, and your solution is actually one of the very outstanding, great item there. Anyway, just quick question. So you obviously you have some kind of IP filed. I got just a couple of questions here. So first about if you just tell us a little bit about your IP. And then also, do you have any? Sound like you have already widely used. You mentioned the interest in Japan as well, but I do actually have a strong interest in another part of Asia right now, being an office presence in Asia. Yeah. So, do you have any use case and maybe customer, and as a maybe semiconductor or somebody in semiconductor industry? If you have liberty, maybe you can share those both items. So in other words, to summarize IP and then any use case and customer. Case that you have.
So the core IP is around the reactor design and the electrode design itself. And then we've supplemented that with other filings on how the system is used in continuous operation, where we circulate material through, we feed, recirculate, and then bleed the treated material out the discharge side of our system. And then also treating very heavily concentrated streams via a batch mode of operation, where we're basically filling up and recirculating over a period of time to break down PFAS compounds and then discharging the whole volume that we've been treating. Then there are some other supplementary or additive chemistries and things that we filed on as well. So that's the nature of our IP. Lots of trade secret as well, which is important. And then in the semiconductor industry, I don't think I'm at liberty to talk about many of the companies we're working with. Large logic manufacturer based in the US, large memory manufacturer based in the US, and then silicon carbide producer, as well as an analog semiconductor chips producer who are interested. And we've done a lot of work on where in the process flow we need to focus our efforts and which streams we need to segregate. In the battery space, we're newer at working there. It's mostly with the recyclers who are dealing with, as they're breaking down battery materials. Yes, their wastewater streams are low levels, but significant levels of PFAS that we want to help them deal with. We're at early test stages of that now.
Thank you.
Perfect. Keith, and then Adarsh. Then we have to wrap up.
Great. Yeah, thank you, John. I'm glad to see you guys exploring these other market possibilities, and wondering. Oh, sorry, got distracted by notice on my screen here. Wondering what you're doing in terms of market segmentation to prioritize those different markets. And then as a separate point, as I already know the answer here, but I think will be relevant to other people here, the Okta system that loads into a standard container, as I understand it.
Correct.
And can be used for portable on-site temporary remediation and then moved on to other sites. Is that correct?
That is correct. Thanks for bringing that up. Yeah, I appreciate your questions, Keith. The beachhead market for us, the first market, was in this landfill space, the waste management companies who operate landfills, even municipalities who run landfills in their municipalities or their counties. Those landfill operations, they've borne the brunt of everyone's use of products containing PFAS compounds, whether it be carpets, personal care products, you name it, paper goods. So they end up with both the legacy materials in their landfills and then newer compounds that are in use today, right? They've accumulated 20, 30, 40 years of PFAS compounds in closed cells in landfills, as well as operating in new cells in landfills. So that's been the primary market at first, but we realized we need to expand out into other places. So we've had pull by a numbers of industrial clients, and then the groundwater and soils remediation engineering firms who they want to destroy instead of shipping off PFAS that they captured into carbon or in media out to landfills or incinerators and things like that. So those are the three key areas. A lot of the remediation projects are dealing with former use of AFFF firefighting foams. Those are the kind of the contaminants that are causing these groundwater problems for the most part. There's also a lot of former electroplating or metals finishing shops that in their baths or in their operations, they've used a lot of PFAS compounds over the years, and found those getting into groundwater near the production sites. So those have been the key areas for us so far.
That's great. Thank you. I would encourage you to keep doing more work on market segmentation, as there are a lot of different markets that you can pursue here.
Thank you. Very, very good.
Okay, we have time for Adarsh, one quick question, then Raymond, I'm sorry, but we're really short on time, so we're gonna have to you can ask him in the over email or in the chat, I'm sorry. But Adarsh, go ahead.
That's okay. I'll answer a couple in the chat. Yeah, because there were a couple more questions. I'll do that
Yeah,
on the
thank-
side. Thanks for
you,
your time,
John.
everybody.
Wait, Adarsh has one last question.
Oh, good. Thank you.
Yeah, John, thanks. Question is around the concentration levels. You mentioned high concentration. What about lower concentration levels? And then subsequent question is it a single pass or multiple pass? And what is sort of the volume or capacity in terms of volume per second or per minute that you can process?
Okay. Actually, you know what? I'll answer that by writing a paragraph into the chat area because, yeah, what you're bringing up, it's a longer answer, I think, than I have time for. So I'll do that right now on the side.
Okay,
And then
thank you.
I'll leave my email behind so we can continue if we need to.
Thank
Yeah,
you.
thanks for your questions. I appreciate it.
I appreciate it. I appreciate it, John. Thank you so much. And yeah, definitely via your contact info. Next up, we have Superseed.
All right, thank you. Let me just get my presentation up here. All right, so we're Superseed. We are a green buildings materials manufacturer based out of Phoenix. I'm Sean Peterson, co-founder and CEO. Joining me is our COO and founder, Jordan Darling. The goal at Superseed is really simple. We are looking to build superior performing building materials that are better for the environment at a reasonable price. The first product that we're tackling right now is wood-based sheathing. So think your standard OSB plywood or marine grade plywood. Where we see some of the issues is really starts with the fact that it's just an outdated product. First and foremost, we're out here looking at lumber yards that are attacking and harvesting weaker and weaker trees, younger and younger trees. But it's also an incredibly complicated supply chain. So we saw that in COVID, where all those intricate pieces from the lumber yard to the mills to the distributor create a number of failure points and weaknesses in the system. And through COVID, we saw a massive spike in price fluctuation. Wood also, because it's weaker and we're harvesting these weaker trees, needs to be able to keep up with new standards. It's getting filled with new chemicals, with new toxins, formaldehyde, CCAs, in order to help this material last longer. But ultimately, everyone knows if you ever build a house, that first sheet of plywood on your pallet and the last sheet are always useless, and if not, some more in between. And at the end of the day, it's the enemy of moisture. It doesn't last, it warps, it splinters, it's difficult to work with. Those are the business cases for it. Those are the practical use cases for it, but there is an environmental case for it. And that is the fact that there's going to be more plastic in the ocean by weight than fish in about 10 years. In addition to that, we're chopping down millions of acres every year. And if you're a proponent of saving the environment, cooling the planet, trees are the best avenue to do that. And the shame of it is going to be to building what's basically a faulty product. And that's where Superseed comes in. We are using recycled plastics and turning that into a valuable product that is inherently 100% waterproof, but it, at the end of the day, is a better performing product overall. We start with kind of the heart of the business, which is three parts. We've got the material science aspect of it. There's a stigma with, across the idea of recycled plastics are weak. We add special formulation. We're using selected source PAR, and we're making that plastic a high performing product. We then engineer that product in terms of that feedstock based on its end use case, as well as engineering the mold design for high capacity outflow, and then putting it through our manufacturing line today, which is leveraging that machine design and the material and the capabilities to produce high yield, high quality, highly consistent products that can effectively displace plywood. And that's where we landed today. It's our first product, and the benefits are clear, right? You're going to have a consistent product that's going to be 100% waterproof. It's always square, and there's no extra formaldehydes. You're not sleeping on a bed of CCAs at night when you're built. And it's in these things that, at the end of the day, elevate us above where wood sits, but it's also structural. And that, for us, is the thing that we're most proud of, that we've been able to produce an actual structural 1-to-1 equivalent for plywood, and we can do that at scale. Where we sit today is focusing on a really focused target market that is hungry and in pain. So we're working with some of the biggest boat builders in the United States today. Pretty obvious there, they need waterproof plywood. In that, what we found is that even the highest performing marine plywoods, which are laden with the most chemicals, actually have the most fluctuations in their performance in terms of sampling across hundreds of samples. So right there, we have a really great alternative. We have been gearing up production for that specific market, and the testing has been going fantastic. As we scale through that and build up, our goal is to continue to replace other wood-based materials, ultimately landing ourselves in the construction market, where we've identified a means to create a cost-competitive alternative to the sheathing that we're building houses with today. And the impact there is that it's a higher performing product that's better for the human being, that's better for the environment that it sits in, and is going to last significantly longer. It's a large market, so where we're egotistical enough to try to approach something like this is really in the core of the business itself. So this is back to that supply chain piece. Every single one of those is handing off another iteration of that wood sheeting product to another person, adding another layer of intricacy or failure point in the supply chain. Ours is vertically integrated. It's super simple. We take some plastic feedstock in from a defined recycling partner. We add our materials, we extrude them, and 120 feet later, you have a perfect board. So this is just in time, it's vertically integrated, and we're really eliminating a great deal of variables that we have in the system. As far as traction goes, where the company sits, we raised $2.5 million. And in the last 6 months, we've been able to stand up a factory. We've been able to get through the ICC certification, which is the main staple for being structurally rated. We're now going through that laboratory testing, which is life cycle testing, takes a few months. And we've also been able to get POCs with 3 of the biggest boat manufacturers in the world. We're quickly seeing, as we're booking orders and booking capacity, that it's time for us to raise. So we're going to raise at the end of this year and into Q1 of next year in order for us to secure our next facility. What's most compelling from a business model perspective is that this is a really CapEx efficient business. We have a rate of return on these machines that's within 18 months. And there's not a lot of businesses that, I've seen in my tenure that can turn $7 million into $65 million in top line in 2 years. But for this crowd, what we're looking for is that we're fairly well versed in OEMs in terms of trailers, RVs, and boat manufacturers. But there really is a great deal of interest, at least what we see from a product market fit for some of the contracting opportunities that are open. We think this for basing, whether they be permanent structures or temporary structures, Superseed is a really great product to displace existing sheathing. Also, we have a lower cost model that is even more lightweight, still waterproof, and it's a great displacement for some of the 1/4-inch sheathing that you'll see on building out crates. We'd love to get in touch with anyone in the logistics arm doing that. And then also on our roadmap, part of our core process is creating new compounds. We're experimenting with things that increase strength in all manners, and we're currently developing a ballistics panel, which will help create a lightweight ballistics panel for us. So that's us overall. Happy to answer any questions. Thanks.
Thank you. All right, Adarsh, go right ahead.
Hi, thank you for the presentation. I have a question related to the construction sector.
Sure.
In terms of the performance of your product, can the waterproof membrane or sheets, can that be replaced for buildings? And the second question is, can you talk a little bit about your IP?
Sure. Yes, it's a 1-to-1 replacement for plywood and OSB as it stands today. We can also, I think if the question is replacing some of the waterproofing barriers, yes, we can eliminate a lot of the needs of secondary materials that are applied. And as far as IP, I'm going to let Jordan chime in on that.
Yes, thank you. So on the IP, that's what the fundamentals of this company was founded on. Is we spent the first 1.5 years developing the technology and developing the patent, and the patent is around the extrusion of plastic materials for construction sheathing. So that will apply to the construction market. That'll apply to any of the marine grade markets we're working on. But in essence, our process is hollow board extrusion for sheathing products. And that's a utility patent. And then we also have a tremendous amount of trade secrets in that space. And we're actively looking to expand upon our utility IP, both in construction and outside in other markets.
Perfect. Next up is Han. Go right ahead.
Hello, hey, great presentation and great technology. Actually, appreciate it. It's I got just quick couple of questions here. First of all, which material would be the most compatible competing product? Okay. Also, what about the cost competitiveness? Can you elaborate on that? Actually, I'm also a investor in commercial real estate development. So I'm actually having personal interest in your material, actually. So maybe you can elaborate those two. That'd be great. Thanks. No, maybe you can have a chat later about that too. Thank you.
Yeah, please. I'll share my email. It's up here as well. So the competitive products, most namely, would be marine sheathing. We are a 1-to-1 replacement for that on cost. We actually come in a little bit under cost on those. Outside of that, particularly in the OEM industry for either trailers, RVs, boats, where they're looking for a true waterproof solution, there's nothing close in terms of performance, and there's certainly nothing close in terms of price. The closest price comparative, the closest waterproof sheathing that is of relative strength capabilities is about double the cost. So we're really trying to make this a no-brainer. Because like we said, marine construction is just where we want to enter, and then we're going to continue to drive costs down, ultimately landing ourselves at a engineered plywood price point with a 15% gross margin.
And then just that works with other material pretty well.
Yeah. In terms of, do you mean in terms of interaction, adhesions, etc.?
Yeah, correct. Yeah, exactly. Yeah,
it does. We also have developed specific adhesion promoters that we can add if there's a special use case as well.
Okay, maybe we can have a chat offline. Thank you.
All right, Raymond, you're up.
Yeah, it's just quick question about what type of feedstock, any requirement of the plastic? Is it using mostly PET or PVC or PPO? Doesn't really matter. How does that impact your performance? Just basically the feedstock and the composition requirements.
Yeah, consistent high density polyolefin is what we're looking for. Right now, polypropylene is the main feedstock that is abundant. It's typically overlooked. Folks are really interested in PET when it comes to recycled plastic, so there seems to be a great deal of PP out there. So we're starting there, and that's working for us. We're always open and on the lookout for looking at new materials to integrate into our manufacturing line. But right now, PP is the main feedstock.
And then one other point I'll add on that is we've tested it both ends of the spectrum. We've tested it, I would say, less than clean or ideal recycled polypropylene, mean it was taking off one assembly line, simply ground, and then put right back into our machine as one end of the spectrum from a, I would say, less than premium standpoint. And then we've had very pure PIR that's been post-processed with all the additives put in, also put in a machine. And we've been able to make products from both sides.
Yep.
Perfect.
Thank you.
All right. I want to get to one more question. Bill, go right ahead, and then that's the last question.
Yeah, thanks. I just want to follow up on the feedstock. So how secure is that part of your supply chain? Understanding that today it's focused on polypro, is it easy to get that stream?
Yeah, right now it is, because again, polypro is one that's overlooked. Now we're constantly, it's just part of our business model, is bridging new gaps. So I think what we want to highlight here is just the efficiency of the plants themselves, right? So we're extruding out of that one line right now. We have the capability of producing about $12 million a year. That takes up about 10,000 square feet. So what we're able to do is actually co-locate these micro plants near densities of feedstock that are being produced. We're talking to partners in waste recovery. We're talking to direct manufacturers, that have offcuts and are paying right now currently to cart them out to a recycler. So right now we are certainly not worried about running out of feedstock. If we do, I think mission accomplished. So we're marching down that path as quickly as we can, because our goal is to displace as much plastic as possible. But yeah, just to highlight again the efficiency. So we can stand up these plants very quickly, very capital efficiently. But the main comparison is we're about 100 times more efficient from an energy, from a carbon footprint, and from most importantly, a square footage standpoint than a traditional lumberyard. So what they can produce in about 400 acres, we can produce in less than 1.
Thank you.
Perfect. All right, that's all the time we have. Thank you so much, Sean and Jordan. Really appreciate that. Definitely leave your contact information. With that, we're moving forward to session 2. We are not going to introduce the panel in session 2 because we're running a little late. That being said, when you do ask a question on session 2, feel free to quickly introduce yourself. That's totally allowed. I'm sorry that we have to run forward. But with that being said, we are going to start with heat path. Feel free to start sharing your screen whenever you are ready.
Can everybody see this?
Yep.
Sorry.
We can see
Okay,
it.
great. All right. My name is Matt Seabaugh, and I am the founder and CEO of HeatPath Solutions. Today, I'm going to talk to you a little bit about technology we've been developing to begin to improve the sustainability of the specialty chemicals market. There are a lot of different chemicals that are produced from petrochemicals today, are using petrochemical processes that are very high carbon intensity. And what our technology does is shifts the raw material supply from petroleum or natural gas to organically derived sugars. So we refer to the process as sugar to X. And I'll be talking today about a specific beachhead market we're interested in, which is the adipic acid market, and producing that from dextrose from corn. So hopefully, yeah. So adipic acid is a very commonly used material for the production of nylon. Nylon being a very high temperature, high strength polymer, finds a lot of use in automotive applications, both in tires and under the hood for lightweighting, and more familiar technology or applications include outdoor wear, athletic wear, things of that nature, where the strength and water repellency is particularly important. It's currently made today by a fossil process that's very cheap, uses kind of a byproduct ketone alcohol oil, and they're able to produce this at about $1.80 a kilogram. Unfortunately, it has an extremely high carbon intensity. About 16 kilograms of CO2 is generated for every kilogram of adipic acid produced. When that's about half of the nylon that you're most familiar with, obviously it's a very large problem. Thing is, this isn't new. These aren't new facts. This is something that has been trying to be addressed using dextrose, but using fermentation methods. There has been some success in the market in developing particular boutique brands have adopted a green material produced by fermentation. And while this is able to cut the CO2 emission significantly down to 4 or 5 kilos per kilogram, the cost is also about 4 to 5 times as much as the fossil product. The other issue that kind of goes unspoken about those fermentation-based processes is that for the best integration into the existing supply chain or the actual application, this is kind of this is an adipic acid plant that produces nylon here in the United States, and the idea of incorporating a fermentation-based process, which scales very differently from what chemical manufacturers are used to working with, is it presents some hurdles to adoption, and it is difficult to scale and subject to upset during operation. So a commercially viable green adipic acid process is going to have to scale and integrate within existing facilities, whether that's here at the end use state or back at the dextrose production state. In any case, it needs to be a high volume scalable technology. So for our approach, we're going to take a little bit different direction than fermentation. We're going to start with sustainable feedstocks from corn or from green hydrogen or blue hydrogen for hydrogenation steps. But then we're going to basically borrow the exact types of reactors that are used for fixed bed chemical reactions today. And through the use of catalyst materials that we've developed at Heat Path Solutions, we're going to go ahead and allow them to run in what I sometimes refer to as the gentle cycle. So rather than the aggressive high temperature, high throughput mode that generates a lot of excess heat and potentially a number of byproducts, we actually run this system using a different catalyst approach that will allow selective and productive application. So conversion of these very delicate sugars into the proper molecules as opposed to just burning them up and making caramel inside your reactor. So this allows us to use low CapEx, low OpEx reactor designs with about a century's worth of design and development built into them, but a new catalyst that allows us to produce sustainable specialty chemicals like adipic acid at about an order of magnitude lower CO2, about 1.2 kilos of CO2 per kilogram is what we project right now, and that cost will be on par with fossil-derived material.
30-second warning.
Jeez, okay. So in comparison to existing technologies, we've got both the product scalability and cost advantages. We're looking at a specialty catalyst market, a chemical market of about $400 billion, but we're targeting nylon and its intermediates at about $10 billion, adipic making up about $6 billion of that. And we're seeking a lead investor for a 1.5 pre-seed round. In this, we will build a skid-mounted reactor to demonstrate the technology and de-risk the process. We have our reactions demonstrated, 3 patents are filed, and we have NDAs with 4 different adipic acid producers. We're in 3 prominent accelerators, most recently Venture for Climate Tech in New York State, and we have won a business model challenge from the National Corn Growers Association. Here's my team. I just emphasized that in addition to myself with 25 years of experience in materials engineering, I have 2 partners who have over 30 years experience in the chemicals industry and standing up new businesses. Thanks.
Perfect. All right, opening up the floor for questions for all the panelists who are just joining. You can ask a question under the React little button on your Zoom menu bar. But if you can't find it, feel free to just pipe up and we'll go in the order of hands raised or, piping up. Perfect. Andrew, go right ahead.
Thanks. And thanks, Matt. Question for Andrew Finkelstein with Ag Thunder. We're an early stage venture capital firm. What has to change process-wise in order for you to, say, conduct a proof of concept with an initial customer? And is this live in any site to date?
No, we're looking to build that skid reactor. What will need to change is that we would take dextrose being the feedstock into a new reactor, and then our catalyst would be swapped in, for that in the packed bed reactor design. We would anticipate that it would integrate well into facilities. It would be a familiar style of reactor and all that sort of thing. I wouldn't necessarily be taking a Ka oil, reactor and filling with a new catalyst and just going from there. But the integration will be much more familiar and simpler than a fermentation-based process.
Perfect. We have time for one more question. It looks like no, there's not one in the chat, but we have time for one more question if someone wants to ask a follow-on or a question. Otherwise, I mean, could you elaborate a little bit more on some of the use cases that you have?
Sure. So we are looking principally at conversion of adipic into first gluconic and glucaric acids as well as adipic acid. So those are 3 products that we have. In addition to that, we have opportunities to look at the production of sorbitol from dextrose, and then also the conversion of sorbitol to isosorbate. That's a sustainable and compostable, I suppose I should say, plastic. Other aspects of the technology, we're looking at things in consumer packaged goods space for cosmetic applications, making glycolic acid, as hydroxy esters from dextrose. These are very high margin, smaller.
Matt, I think your volume's a little low. Would you mind? I don't know if you can move closer to the mic, maybe, if that would help.
I'm sorry.
Oh, there you go.
Okay. So, yeah, we're looking at glycolic acid and alpha hydroxy esters as other potential products in the consumer packaged goods space and cosmetic space. But the one of the principal ones that we're focused on at the moment remains adipic.
Now, I know there's a decarbonization narrative, but is there any I guess superior elements functionally also to leveraging your catalysts, either the ones existing or the ones in the pipeline?
I would say that in terms of the production cost is going to be similar for the adipic acid process. But right now, the brands that can take on the carbon intensity aspect, that additional value, they're able to attack the green halo kind of market space. And we're not looking to sell this product to take advantage of a green premium. We're instead looking to apply it in a way that end users can point to having a green feedstock chain or green nylon and be able to offer that at the same price they would a conventional product. When I've looked through, in our analysis, brands that can do that get about 34% faster growth if they're at the same cost and have that green narrative. If there's a significant green premium, however, that all goes away. So we're looking to offer end users who are focused on carbon intensity a path to achieving better profitability.
All right. Thank you so much, Matt. I think that's all we have time for, but I appreciate the presentation. Feel free to leave your contact information in the chat.
Yep, I will do that.
Folks will reach out. Next up, we have Pure Fresh. Feel free to start sharing your screen whenever you're ready. Christian, you got it?
Yeah, can you hear me?
Yep, I can hear you. I can see you, but I can't see your screen yet. There, it's coming.
How about now?
Perfect. I can see it. Not in presentation mode yet, but I'm sure that's the next step.
We'll get there. There we go. All right. Thank you, everyone. My name is Christian de Blasio. I'm with Pure Fresh Clean. We're based out of San Francisco, California. Just want to give a quick thank you to Deep Tech Showcase and Eagle Point Funding for hosting us today and bringing us in. Really grateful to have those two partners. We are in, when you talk about clean tech, we're clean, all right, and we're tech, all right, but we're not the normal kind of clean tech that a lot of people are thinking about these days. Some of the issues that we solve in this world have to do with odor, mold, mildew, germs, bacteria. 5 million people in the U.S. alone develop chronic diseases every year from some type of black or other type of mold inhalation. Other issues and things that people throw at these problems nowadays is a lot of chlorine, lots and lots of chlorine. And the main, chlorine itself is carcinogenic, and chlorine fumes, either in the pool industry or commercial cleaning or household cleaning, over inhalation of chlorine fumes kill about 25,000 people per year. Another market that we touch on, the pest and rodent industry, uses a lot of poisons, sticky traps, a lot of dangerous things that end up being around restaurants and food. And they're the last things that you want around restaurants and food, both the pests and the poison and chemicals and sticky traps used to kill them, but that's the world we live in. It's a very quiet world behind the curtain that no one really lifts up that often, and that's what we're doing with our disruptive oxygen-3 technology. A lot of opportunities in the post-COVID world for non-labor cleaning technology, which is what we do. The three key pillars of the areas in the solution centers that we operate in are deep odor removal. So think about smoke, fires, pet, mold, mildew, spoilage, cigarette, marijuana. In residential situations, Stanley Steamer and their type of activities, Enviromaster, working in restaurants, things like that. Keeping places cleaner when people vacate homes, short-term, long-term properties. They generally have lots of bad odors and bacteria from all these things, and our technology takes care of that problem overnight. Rodents, pest removal. So when I talk about removal, we're not talking about killing, we're not talking about traps, we're talking about a new application for nighttime non-occupied facilities like restaurants, breweries, and bars, where we operate our systems in the cloud on automated schedules when no one is there, when businesses are closed and locked. And when you operate oxygen-3 at the very low dose levels, you force rodents and pests, bats, birds, rats, mice, cockroaches to leave the facility. And then heavy disinfection. So a lot of times when people need cleaner areas or are afraid of their areas being contaminated of certain bacteria, we have the application to solve that. Also, a very attractive solution in the agricultural industry when we talk about heavy disinfection. So our primary and secondary markets here, primaries are restaurants, breweries, and bars, residential and rentals, as I mentioned, and secondary agricultural yachts and boats. So again, just to hit on these four categories, if you're restaurants, bars, and breweries, we deploy a solution. It operates overnight on an automated schedule. It reports data to the cloud. It monitors itself. And it not only removes all the pests from your facility, but also cleanses the facility, air and surfaces from food poisons, bacteria, E. coli, salmonella, and makes the place safer to work with. Oxygen-3 is USDA certified, FDA certified for food contact, organic food contact. That means that if there's drinks or food or fruit or products that are open or exposed to the oxygen-3 when we treat it, after the oxygen-3 is gone, it is 100% safe to eat and organically treated by oxygen-3. Residential rentals, another one of our markets. So again, as I mentioned, we're really big with property management companies, property management that big corporations that handle hundreds or thousands of properties, either short-term or long-term rentals. When they turn over the properties between tenants, they come to us for solutions to clean the facility, to get the odors out, long-term odors that just won't leave the facility, whether it's smoke, tobacco, marijuana, people, pets, what have you. Agriculture is something I have a deep background in. That's where I got my start in ozone 20 years ago. And we adapted the product to still have a solution for that industry. Typically in ag, you have ozone oxygen-3 systems that are in the, whether it's Tyson Foods or whether it's Nature Right Berry Company. A lot of the systems for land-based centers for food production are in the $500,000 to $2 million space. And we offer solutions to cover 10,000 square feet for less than $8,000. So really focusing on the one key market here, which is the restaurant, bars, and breweries. We're currently deployed at over 100 restaurants, bars, and breweries in the United States. We're heavily infiltrated in California, but we have clients around the country now in North Carolina, South Carolina, Florida, Texas. We're in Alaska. And because of the ease of deployment of our technology and the remote control, it's very easy for us to manage deployment and scaling. And that's what we're looking for money for right now. A lot of the brains of our technology is in the remote control. So there's hundreds of systems out there that produce oxygen-3, things that you can buy on HomeDepot.com or Amazon.com, a lot of products made in China. There's zero products out there for the average buyer, B2C or B2B, that can buy a product that can tell you what the O3 level is in the air. It's almost unheard of to have a product that can say, this is the air environment, this is how much oxygen-3 is in the air, and this is the challenge you're trying to accomplish. A lot of this is built around our IP and developing recipes and formulas, patented formulas that say, if you want to solve this issue, you need to maintain 250 parts per billion for 45 minutes. If you want to solve this other issue, you need to maintain 2,000 parts per billion for 36 hours. And that's the type of thing we do. That's where our experiences is. And there's really nothing around that has that type of capability to measure with O3 sensing in the air what's happening and maintaining the levels with remote control, with remote reporting.
30-second.
Very big industry. It's upwards of $300 billion, and us just looking at 0.5% of that is already putting us down the road into a $1.5 billion revenue target for our company. Some of the names that we're in already that are buying our products: NFL stadiums, Stanley Steamer in over 25 franchises in the United States. The business model, real quick, is system monthly lease and or purchase with annual subscription lease. The monthly subscription is an annual subscriptions after purchase cover updated software and maintenance. Our gross margins are extremely high. We've been able to build a product with great technology at very low cost. This is where we are today. We completed a 2022 seed round of $750K. We've used all that money, and we decided to hold off for a year on going into a seed round to see what we could do. We have a small payroll, and we had a very fast revenue startup, able to go from $50,000 of revenue in 2022 to close to $500,000 last year, and then close to what will be $1 million this year. We're looking for chunks of investment of about $400,000. For that $400,000, we're offering out about 12% ownership. Looking at a maximum investment right now for the seed round is about $1.5 million. We've got a data room up and ready to go. And most of the funds that we'd be targeting, the use of the funds that would be coming in, are really for scaling right now. It's a lot of sales, marketing, innovative marketing with social media and AI, and a smaller amount needed for continued engineering, because we've got a lot of that accomplished already. So again, my name is Christian. I'm the CEO of Pure Fresh Clean, based out of California, and would love to hear if there's anyone out there that has some questions or would like to talk to us more about entering in as a major player in our seed round.
Sure. Bill, go right ahead. You're fast on that one.
Yeah, I'm just curious about your supply chain and your manufacturing capabilities. How is your equipment being made?
So we've made it with a small staff out in California for the last year and a half. We're about to move to a major third-party facility in Racine, Wisconsin. So we've had a handful of people doing it now, and we'll go to a third-party manufacturer by the end of this year in Racine, Wisconsin.
Okay, so the solution long-term is not investing your own capital in a manufacturing facility, but outsourcing.
Correct.
Okay, thank you.
Perfect. We have time for a few more questions. Otherwise, I'll ask. I have a few good ones. Christian, I was curious, when do you think, because as I understood it, you're still doing a lot of the, you've mostly done with engineering, but when do you think it would be on the market by?
We've launched. We're on the market now. Really, we're one of these companies that has the product. We've got the customer referrals, the big names from Stanley Steamer, Raymond James Stadium, and NFL Stadium ownership, to small people, property management companies that are managing, 100 or 500 properties in Texas and Florida that have used us. So we need help scaling in this modern world of advertising and AI, social media, cost expenditures. That's where we need to put our money in now, is just to scale the sales of the product.
Sure. All right. So it looks like other people have questions now. Andrew and then Thomas.
Christian, couple questions. So around Moat, is there IP tied around this? And then also, so Oxygen 3, this isn't my area, but I assume it's ozone. And then the question is, are others involved in distributing ozone in this way? Or could they, if they caught wind of you being so successful?
I'll answer your second question. You asked about moat.
Yeah.
So-
One of this is Pure Fresh, and Pure Fresh is only.
So the key IP that we have and the patents that are filed are around the restaurant applications. There's that I've been through successful, unsuccessful patent applications. I've never felt as strong as I do with what we've paid to get researched by the legal team and what's now filed and pending for the restaurant industry. So no one's ever done anything worldwide for commercial use for pest management of food facilities, restaurant facilities. And that's our strongest lock right now for protecting our future. The other areas that we're in, there are other ways to use ozone or oxygen-3, although the remote sensing is what's really, really hard, and you don't see any of that out there.
All right, perfect. Thomas, you're up. Last question.
Yes, I'm wondering are you an alternative that you're displacing somebody, or are you finding that your customers don't have a solution now and they're willing to try the ozone? And just out of curiosity, it sounds like this poisons the animals. Essentially, ozone is damaging. Is it a safe product?
So we are displacing other players in the industry. So in the restaurant industry, we're replacing pest control companies. So think Orkin, other companies that have poisons, sticky traps that you won't need to buy anymore. You won't need to treat your facility with poisons and traps. One of our end goals, just to let you know, is one of our visions of exit is a $50 to $100 million exit to be sold to an Ecolab. So everyone out there knows Ecolab. That's the kind of company that has invested some money in low. Restaurant industry. Nothing like what we've done in the restaurant industry. But again, we're replacing technology.
Is there a safety issue with pumping out ozone into space?
Our application is very specifically designed to be in environments where humans are not. And everything we do avoids human contact.
Gotcha.
All right. Thank you so much, Christian.
Thank you.
Yeah, feel free to leave your contact info. Next up, we have Eternal. Feel free to start sharing your screen whenever you're ready.
Sounds good. And you can hear me okay, Asher?
I can hear you loud and clear.
Fantastic.
We can see it. Yep, now we can see it.
Awesome. Sounds good. Thank you. So I'm Ryan Hackler, co-founder and CEO for Eternal Upcycling. And the headline for this presentation is that we can achieve a sustainable future through plastic upcycling. And the fact of the matter is that we need to. What we're currently doing is just not working in terms of end-of-life prospects for plastic. We generate 51 million tons of plastic waste in the US, with only 5% of that being recycled. The problem is ultimately that we have a linear carbon economy. We extract carbon materials largely through petrochemical refining, turn those into valuable goods, use those goods, but then simply discard them into landfills or to incineration facilities, or even worse, into the environment. And so the best solution is to establish a circular carbon economy where we cut out the streams to landfilling and incineration and instead divert those materials back to producers to manufacture the same types of goods that we use every day, all while reducing extraction and eliminating loss of materials. And so that's what Eternal Upcycling is focused on. We've developed a technology where the focus is that we buy plastic waste streams from waste management companies and other partners that sort and pre-treat their plastic waste so that we can break it down using our patented catalyst, our process, and hydrogen gas called hydrogenolysis. The idea being that we can essentially take this molecular chopping technology to give us waxes, lubricants, sustainable aviation fuels, basically other cuts of petrochemicals that largely come from that petrochemical refinery apparatus that are similar in structure and performance to existing products on the market. That means our products, these plastic-derived equivalents, can serve as drop-in replacements, making it easier for manufacturers to implement a greener alternative that allows them to reduce their Scope 3 emissions by 1.5 tons per ton of plastic-derived products used. Now, the current state of the art for plastic recycling largely aims to fully break apart those plastic materials into their smallest components, and then reuse them to go back to plastic materials. But what we're aiming to do is a little bit different. Instead, what we're aiming for is just that higher value materials. Again, these viscosity improvers, these waxes, these lubricant oils, these SAFs, with the bonus of reducing Scope 3 emissions, all without compromising on performance as well as the cost for these commodity chemicals. So we don't need to rely on a green premium because the products that we're generating are higher value inherently. That means we have larger profit margins to operate within, which means we can operate at smaller scales and we can truly go after the really unrecycled materials, the materials that currently aren't really processed at all in the market. So our plan is to leverage this molecular chopping technology to create multiple products with big markets. You can see here largely in terms of global production, we're talking base oils for lubricants, waxes, viscosity improvers, and sustainable aviation fuels. But we see US waxes and base oils as a unique opportunity for us to demonstrate traction, improve viability because those are lower barriers to entry at smaller scales. So starting off by producing and selling waxes to manufacturers before delving into the global scene with lubricants, waxes, and SAFs. So in particular, let's start off with waxes as sort of our beachhead market. We see a nearly $12 billion market for waxes, with fully refined and synthetic waxes commanding over $1 billion in the US. And our plastic-derived wax equivalents are easily implementable, they're robust, they're renewable, and they hold a low carbon footprint when compared to the petroleum and bio-based waxes. Candle wax in particular demands nearly half of the wax market in the US, and there's an opportunity here for high profitability because they're more consumer-facing applications. Customers have expressed frustrations in formulating highly scented candles using bio-based waxes like soy wax, even though the end user, their customer, really wants that kind of green messaging associated with bio-based components. And so we see candle wax as a great opportunity for us to help manufacturers lower their costs while maintaining that kind of green messaging and giving the end consumer that kind of high performance and kind of feel good message that they become accustomed to. So to that end, we've received letters of support from candle manufacturers that are really hungry to use our wax at scale. And that's what we're aiming to do as we scale up our technology and ultimately our process. So the team is composed of myself and CTO Robert Kennedy. We both got our PhDs at Northwestern University. We then went on to work as postdocs at Argonne National Lab, where we invented the core technology. This was fundamental research that was funded by the Department of Energy. We then went on to participate in chain reaction innovations. One of my colleagues, Kevin, was also participating in CRI. The focus being there that we can take a DOE interested technology and scale it up and actually show that it can work in the real world, which is what we've been focusing on. We have Max Del Ferro from Argonne and Haven Allen from EBHUB as advisors that have helped us in scaling up and deploy that technology and really kind of demonstrate the appetite that it has in the market. So since founding Eternal in 2022, we have demonstrated that it works with real-world plastic waste, that it works at the lab scale. We have a number of patents and patent applications that we've submitted for, and we've received letters of support from customers that are really interested in getting kilograms and then tons of material that they can test it so it can actually be implemented into their products. We're now focused on kind of further designing and testing reactor systems, kind of solidifying our IP portfolio, really getting prototypes into the hands of customers, like I said, in the kilogram to ton scale, and really validate the catalyst lifetime. It's kind of the core IPs situated with that. So then we can then get on to pilot plants, paid pilots, showcase finished products, going on to the demo scale, we're talking 40 tons a year, and then finally to full commercial scale, ranging from 10,000 tons to 80,000 tons per year, as we scale up and show that we can be profitable at that scale in comparison to some of the other chemical recycling technologies that really need to operate at much, much larger scales. We're talking hundreds of thousands of tons, upwards of 400,000 tons before they can even really consider the possibility of being profitable. And so with that, happy to answer any questions. I was a little light in terms of the technology. Happy to answer any questions on that. We are opening a $2.5 million pre-seed raise. That's to focus on building out our team. As I said, develop kilograms and upwards of a ton of product prototypes that we can send out to customers and really scale up our operations. Happy to drop my email in the chat. It's located here as well. And happy to answer any questions.
Sure. Thank you so much, Ryan. Feel free to opening up the floor. Whoever wants to go first, feel free. Otherwise, all right, Thomas, you're up.
Yeah, well, I could spend all afternoon with this exciting story. So, how many people? Is it just you and your founder, or do you have you built a bigger team? That's question one. Two, what do the economics look like? Do you think you're going to be able to match the existing wax feedstock?
Yeah, absolutely. So first question, the core team is just myself and Robert. We were inventors on the original technology. So part of this raise is to kind of build out our team. We're chemists by training. We know the catalysis technology very well, but we definitely need to build out to kind of get that engineering expertise in-house to further build out from there. And then in the second part, we have done techno-economic analysis to show at kind of what scales we become profitable. When we're considering the first commercial scale, 10,000 tons to, let's say, 40,000 tons per year. At that scale, our unit cost is about $600 per ton. And that's in comparison to the price point for these, fully refined or synthetic waxes ranging from $1,500 to $2,000 a ton. So that's a pretty healthy profit margin, around $1,400 that, when we're talking about scaling and really dealing with the real world plastic waste, if there's any kind of other cleaning separation processes that we need to incorporate that we're not currently accounting for right now, we can soak in that cost. Thank you for the question.
Where do you plan to get the hydrogen from, and which color of hydrogen are you looking for?
Yeah, so thankfully, again, through techno-economic analysis, we've shown that the cost component of hydrogen is relatively small. We're talking 4%. So we can be quite agnostic for hydrogen. Ideally, we would like to get, green hydrogen, blue hydrogen incorporated into our process. That can be dependent on where we're located. So again, part of our business plan is to kind of co-locate near waste management companies or municipalities that have large nexuses of waste streams. Because of that, that might end up being a little bit trickier depending on where kind of the nexuses for green hydrogen or other sources of hydrogen are. So if needed, we can either install our own water splitting system to generate hydrogen, or if we really need to, we can implement gray or brown hydrogen. But again, we recycle all of it. There's only a small percentage of it that is consumed. And because it's such a small component in terms of the cost of our operations, it really doesn't make a big difference for us in terms of the bottom line.
Perfect. Perfect. Well, thank you so much, Ryan.
Yeah, thank you.
Feel free to leave some information in the chat. And yeah, thank you for the presentation. All right. We have one last presentation, potentially. Barry, I don't know if you can hear me. They're having weather issues, so I don't know if they're able to present. Barry, if you're able to, happy to have you. Otherwise, we can do a rain check and we'll have you at a future event. All right. I'm not sure if he's able to, considering the weather circumstances. So I appreciate everyone joining us. Thank you so much. Stay tuned for the energy showcase, which I think has some overlap to this one. And feel free to join us. We're also going to be hosting, I know that Lisa's on the call, I have to also let you know, we're going to be hosting a similar showcase in November in partnership with GC Ventures, as well as some other folks that I don't know if I'm allowed to mention yet. So we're really excited about that. Stay tuned for that as well. We're probably going to have, some really interesting companies that are relevant to this field. So thank you everyone for presenting. Thank you for everyone for being on the panel. And thank you for all the attendees watching from home. Have a good rest of your day, everyone.
Thanks.
Absolutely.
Thank you. Bye.
Have a good one, everyone.
Bye.